This is the fifth part of the video. These programs I have not yet tried, so it'll be my first time trying them. And the rest of these videos will probably be a lot of problem solving and I guess me being stuck in some parts. I've heard this game is actually hard and it gets much harder, so hopefully there is something valuable from my mistakes that I'm going to be experiencing in these programs. So this is the signal multiplexer. So it reads a value from in.A and in.B. Read a value from in.S. Okay. Read values from in.A, in.B. Read a value from in.S. Write in.A when in.S is equal to -1. Write in.B when in.S is equal to 1. Write in.A plus in.B when in.S is equal to 0. Okay, so it's similar to our previous answer, except we only have one output. And we'll be doing lots of conditions on it. So my thought process is, sorry for hitting the microphone, is I'll bring in.A into in.S, in.B into in.S. I will, I'll move it down, and this game actually only restricts you to write code these amount of lines, so around 15, my guess is. So that's why you don't want to put lots of spaces. And I think I can fit this here. Yeah, I can fit this here, where I'm just going to do, I'm going to check in.S here, and I'll say, let me check the manual. So in assembly, there usually is a compare, and you can compare for like -1 and stuff. This doesn't have that. Let me see. Yeah, I guess there is a way. I can assume that in.S will only be -1, 1, or 0 from the look of this, but the program doesn't specify this. So let me just quickly look through it more and see if I can somehow compare for a literal number. Well, the name of the program is called a signal multiplexer, and in a multiplexer you don't usually, a normalized multiplexer would have values of -1, 0, and 1, but you can definitely go in a higher range, so that's wrong actually. So I'll assume that it can only be -1, 1, and 0 at the moment. So I'll move up, right, up, left, up, move up to the accumulator, and then we'll do a couple of checks before receiving these inputs. Yeah, I'll do the first checks. So in that S is -1. So I'll do the checks. Yeah, I'll do the most obvious check, which is the 0 check. So if it's 0, then I'll call it 0. Call it E0. Easy. So if it's 0, then we want to move. Then we want to do add. So this is 0, which means I can actually add left and right without worrying about the accumulator right now, because the accumulator is 0. So that's nice. That like basically probably saves 2 instructions, because we don't have to go back. So I'll say add left, add right. and I'll move down. Right. Sorry, move the accumulator down. And then everything from up I'll move down, everything from up I'll move down. So this is the obvious check, and it's already, you can see that I only have half of the instructions left. So I've been putting spaces just to make it easier to read. And my thought right now is I'm underutilizing the concurrency of this. Like, it would be way faster if I actually gave the in.s to both in.a and in.b, because why? Because it can do the check, and then so I don't have to do 3 checks in one box. I can do 3 checks in 3 boxes, and I'm utilizing 3 of these boxes quite evenly. My instructions will increase. Will it be faster? I don't know, maybe. Okay, let me just solve the problem first before thinking of how I can improve it. So we did the 0 check, and then we can say, we can jump and say if it's less than 0, we can go to the less than 0 check, and that means it's greater than 0 here, which means we'll move the way the accumulator, yeah. So we move the value from left down, and then we'll jump to the start of the instruction. So I'll just call it x, s, and then here I'll move the accumulator down. Wait, so move right. Yeah. I shouldn't be doing this. Oh, it's adding. Never mind. That's fine. Then I'll move from right down. And then that's our solution. But I'll have to make sure to jump to S for this to be fine. So let me step through it. So this gets an input, and this is -1. Now it checks if it's equivalent to 0. It's not. It then checks if it's less than 0, which it is. So then it jumps. So it'll get, if it's less than 0, if I remember, it gets this value, so it gets 7. And it writes it. Oh, it should get 13. Wait, let me see. Yeah, it should get 13 instead. So that was my mistake. Let me see. Yeah, that was my mistake. It should get left and right. There we go. So let's step through it a little bit. Then it gets the value of -13, writes -13. Perfect. Then we get the value of -20, sorry, 1. And we say, is 1 equal to 0? It's not. Is it less than 0? It's not. Then we'll write 7 down. Yeah. So if we run it, many mistakes. -13, then 7. And because we have 1, we want to write 6. Okay. I jumped. So we want to write 6, is that correct? Oh, in that S, write out a lot more. we haven't been reading these values. So if we actually step through it, you'll see that in.s will actually read a lot more values. So we have in.a and in.b. We actually want it kind of level. So we'll actually accept I'll accept it. So I'll say, okay, we can't go down anymore. So I'll remove the spaces. So what I'm gonna do here is I'm gonna say, yeah, give me the value from the right, and I'll just put it into, there's a no up instruction. Add nil. I'll say, no, I'll just say move left to the accumulator, and we'll just. Apologies, I had something happen in reality, in real life. Okay, so we'll actually accept that input from the left, even though we won't do anything with it. We'll put in the accumulator, which is just garbage, because we'll actually put the correct value in the accumulator once we jump. So this is garbage. Then we'll say right is garbage as well. And then now we can step through and see if this is better. 7, 6, 17. Okay. Yeah, there you go. That's our answer. And if we look at this, we can actually return to the segment, and we can actually observe we had 264 cycles, 16 instructions, 5 nodes. I'm thinking, is there a better way of doing this? There probably is. Because if we actually do a bunch of steps or runs, we can see that the first box is idle for 70% of the time. And so is this box and this box. So we're running, and you can see how long it takes. So it's taken a while. What I'm thinking is there is actually a little bit of an efficiency thing we can do. So if it's equal to 0, right? And we're doing 2 checks, and then we won't be doing any checks anymore. We're just jumping unconditionally. So what we can do is actually, instead of making this trash, can we somehow add the accumulator and then add the accumulator and then not jump? Yeah, but we'll move it down, so that'll cause problems. Okay, let me think. Is there a way to make this more efficient, utilizing all of the boxes in a better way? Well, I can, from in.s, I can give in.a and in.b my value. And then I can, yeah, I can like, I read it, blah, blah, blah. And then I say, I do the checks. So I can do the, I guess, equal to 0 check can be here. That's whatever. Yeah, I guess it can be here. Less than 0 can be here. But that would increase my instructions. It would. I guess I can just test it out. So how many instructions does this take again? So let me actually write it down somewhere. I'll just open a notepad. And I'll say 264 cycles, 5 nodes, 16 instructions. So I will go back. I'll actually copy it here. So let me just go back. Did I copy it successfully? I pressed copy. Maybe I don't know how to use this. Okay, I'll just modify this. Okay, so instead of that, is there a way to copy this? Yeah, I'll reference the instruction manual. Sorry, the manual. It says Control C to copy to clipboard. So I'll do Control C and I'll just copy that part. Ooh. It only copies in-game. That's not good. Let me copy it in a different way. Nope, can't even copy that way. Is there... Oh, never mind, it is copied. Yeah, perfect, it is copied. So, yeah, okay, so I'll modify this part. So, the equal 0 check, I'll do the... I'll accept from the right here. And I'll put it into the accumulator, then I'll say J, LZ, 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 and then I'll say this, I'll call this A. I'll say jump A. Then once I check the accumulator and it's less than 0, therefore I will move right, move the accumulator right, and yeah, and I'll read it anyway. So we don't have to use 2 of these instructions, because we'll read it anyway because we're looping here, so that's good. But I'm thinking we'll have more cycles because of this, but we'll see. So that part. Now the less than 0 check. So let me actually remove this. Let me move it here. And then less than 0. Oh, sorry, never mind. This fails the less than 0 part, so we'll just jump straight to A. This does actually do the thing. So we'll move the accumulator right. Okay, we do the same thing kind of here. But I'll call this B, even though it can have the same labels because it's kind of different in a way, I'm pretty sure. Yeah. These are, the separate boxes are like separate programs, but it's all concurrent and it works together. So we can have the same labeled names, which is pretty cool. Move up. So instead of, yeah, it's actually moving right. I don't want that. I'll move up to the accumulator. Here's the big problem. We want to check in.A with in.S. So how about switching these two? So I'll say write accumulator, and then I'll say up accumulator, but I'll move the accumulator so to here. And I'll, instead of putting in the accumulator, I'll just move it right. So we can remove this part. So what it does is it's going to receive an input from in.s, which is -1, 1, or 0. And it receives it, it puts in the accumulator, checks if it's less than 0, and if it's not, it'll just jump. So it won't take the in.a. So we actually want to move up right. We actually do want to read in.a, but just like throw it away. So we'll we'll do move up to the accumulator, but the accumulator will be trash. It's like a no op. But it's a no op which actually reads the value, so it doesn't just like stop. If for example, if our value is greater than 0, it'll just never read any in.a values anymore, because it'll just hop and it'll move. Sorry, if it's greater than 0, it'll just jump back. In.s will be read, in.a will never be read. Okay, so that's that solution. So let me just copy this then. And then I'll say less than 0, I guess greater than 0 for this case. Yeah, that makes sense. Greater than 0. Move right. So from left to the accumulator, it'll do the check and it'll move this left. So then the only check we'll actually need is that check. So it'll move in the S to the accumulator. I guess the easy check, the LZ check don't matter. I'll say move the accumulator right, move the accumulator left as well, here and here. Then I will receive one input back. Move. Ooh. How will I know from who I'm receiving it? Because I can't say receive from the left, receive from the right, because then I'll be stalling. Interesting. That's a big problem which I didn't foresee. Yeah, instead of that, actually, instead of receiving these inputs, I will actually just move it. Instead of moving it right, I'll move it down. Yeah, but then that's only delaying the problem. Is it though? Move up right. Move up left. Yeah. I guess what I can do is I can't do that, can I? Move up right. Move the accumulator down. But if I don't move the accumulator down, that instruction will never execute, so I can't do something like this. So I can't receive this input because this instruction will never execute. Because easy never gets checked. Let me think. Can I somehow still do this? I mean, it has much more instructions anyway, even if this was possible. So what, how many instructions did I have? 16? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I think I counted this. I think I counted that one. Like 22 instructions. And the cycles, are they really faster, even if this was possible? Let me see. Okay. I don't know. I'm receiving inputs from 3 different places. how in the world would I be able to disregard the other two in a way where I can utilize a box faster? Let's actually just step through it, and if it feels slower. Okay, wait, this is a huge problem. Oh yeah, it never receives the inputs. Wait, I think I understand now. Yeah, I think I get it. I think I get it. We don't actually need to use these boxes. What I can do is I can instead of moving the up, I'll move up. I'll move 0 right. Sorry, up accumulator. I have to read the accumulator. I have to read up. I have to read this. And then I'll say move 0 right. And I'll say, instead of doing these checks, I'll just add it anyway. But because it's just gonna give me 0. So I'll do 0 plus 0. Oh no. Yeah, 0. Yeah, I'll do 0 plus 0. I'll do 0 plus, and then this might not be 0. This will be, I guess I'll move it left. Move this right. So it's either this might be 0, so I'll do 0 plus in.b, and then I'll get in.b. Yeah, that seems right. Yeah. So I'll read it. I'll read the accumulator. I'll move 0 left. Yeah. Let's see. It's reading. It has the accumulator of. Wait, this has a different accumulator. No. Let me see again. Why is this -7 again? So it's gonna move it right and left. Right and left. It's probably because it read in.7. It already did the check, so it does not care. And how about instead of having these two instructions? Yeah, how about instead of having two instructions which read up, I will. But it's moving it left, and it's just doing trash things. This. So if I just read it before doing the check, yeah, no, that would cause problems. Never mind. Okay. Okay, this gives me errors, so it gives me -14. So is it off by 1? It's off by 1. Off by 1, huh? Okay. -1, -1. So less than 0. I'll move -13 right. And then we'll move 0 left. Oh, the accumulator. Yeah. The accumulator is trash after this point. So I will add. What would I do? I would make accumulator 0. I would make accumulator 0. Yeah. So it should be right. Ooh. Okay. Let me run through it a little. Boom. This is 0. I think I'm a bit late. Yeah, I'm a bit late. Boop. Okay. 17 and 29 has to add these two together, but it doesn't. Less than 0, less than 0, 0. Okay. I already checked that. Okay. In that S, okay, perfect. 0 is being read eventually. There you go. 0 has been read. It'll move 0 to the left and right. Is there a mistake? This loops back anyway. Zero. Jump less than 0. Oh, jump less than 0. It's not less than 0, so it'll go here. Ah, okay. Jump less than 0, jump. Let me look at the manual. Jump equal to 0. Easy. Yeah, easy. I'll call it A right. I'll rename it A right. And I'll have to do the same thing here. So jump greater than 0, but if it's equal to 0, then we still want to do this execution. So I'll say maybe B right, and I'll say jump equal to 0, B right. And I'll call this B right. And then this should be successful. Yep. Okay. So it's worse. It's worse. By double. And more instructions. Yeah, so much worse. What's the utilization though? It's idle. Yeah, I don't. It makes sense why it's worse. It's idle 50% of the time, but it has to loop a lot more instead of just, you know, putting it directly here and just doing that part. And you can see from the program it takes longer to do. So if we go to the segment list and go here, that's way faster. It actually does what? It does 2 checks, 2 conditional checks, rather than 2 conditional checks here, 2 conditional checks here, 1 conditional check here. So yeah, anyways, I mean, those are 2 solutions, and you know, it's good to experiment, try to find better solutions, and if it's not a better solution, just you know, understand why it's not better, and aim to make better solutions, even when you have one solution. It turned out bad, but you know, I learned something. I practiced more of this game, got a better feel for it. So this was the 5th part, Signal Multiplexer. Thanks for watching.